लो। तो कैसे हैं दोस्तों? तो दिस इज द प्रॉब्लम, and in that problem you see the problem like first surrounded by zeros, one surrounded by zeros. मतलब एक जीरो के बीच के कहाँ कहाँ घिरे हैं और कितना घिरे हैं, दैट्स वी हैव रिटर्न्स here. Given an n into m binary matrix grid, find all the count of all cells containing one that are unable to move out of grid through a path of adjacent first. Adjacent means you can only move in four directions: up, down, left, and right. Diagonal moves are not allowed. Correct? Yes. Diagonal which means from here to here, here to here, here to here. That is not the allow. Right. And now uh, assume that the space immediately outside the grid is an open path, any one located direction on the outer boundary of the grid. First row, first column, last column can immediately step out, and any one connected to it can follow and also step out of the grid. Right. Now I just explained the problem. The problem says that we need to count all ones that are completely enclosed and cannot reach the boundary through connected first. A cell can escape if it is on the boundary, it is connected to a boundary one. So the problem becomes a start from the boundary, all boundaries ones, make every reachable one, remaining unvisited first are trapped, count them. This is exactly the same idea as a number of Clave's problems, right? The approach is DFS, depth first search. We can just assume like whenever we just have to go and start to reach to end, so we have only comes in our mind to graph DFS BFS, but that is the DFS. Why? Because we have to go, but that means first we have to take whenever we just found the one, and then we just have to go depth of that, left, right, top, down. So for that reason we can use the DFS. Traverse all boundary cell. Whenever boundary cell contain one, run DFS, mark all connected one as visited. Final output, finally count all unvisited is, right? Yes. So the boundary is we just assume here, right? The boundary is 1 0, right? DFS from 1 0 is mark visited, 1 0 is mark visited, right? Remaining connected component, this is our remaining component, connected component, right? Cannot reach the boundary, so the count is 3. Like here to this and this and this we can not go because there is the 0 0 and we are not go to diagonal. So for come here and then here, here and here, this is the 3 ones, so the answer is 3, right? I will just write the code, then I will explain how, what is the complexity of this, right? So starting from the here, int yes grid. Now just one we have to take the global int and m, and here is n is equal to grid dot size and m is equal to grid 0 dot size. Correct? Now vector int visited of and vector int m0, right? And here for int j is equal to 0 to j greater than is equal to m and j plus plus. अब now if grid of 0 to j is equal to 1 and not visited of 0 to j, then DFS of 0 j grid and viz, right? And if grid of n minus 1 to j is equal to 1 and viz of n minus 1 and j, right? And then DFS of, here is also DFS of n minus 1 of j of grid of visited, right? And then first count and last count, first count and last count. Here is 4 int I is equal to 0, I greater than is equal to n and I plus plus. Now if grid of I 0 is equal to 1 and viz of I 0, right? And here DFS of I 0 grid and viz, if grid of I m minus 1 is equal to 1 and viz of I m minus 1, DFS of I m minus 1 grid viz, right? Now int count is equal to 0, 4 int I is equal to 0 I, then is equal to n and I plus plus, 4 int j is equal to 0 j, then is equal to m and j plus plus. If grid of I j is equal to 1 and is not viz, then I and j, right? And then count plus plus, and then a return count. I just now write the function of DFS, void DFS of int r int c vector int grid vector int viz, oh sorry, I just take here the first time, then not need to do here. I just start the viz of r and c is equal to 1 int dr of array is equal to minus 1 1 0 and 0 int dc, then 0 0 minus 1 and 1, 4 int k is equal to 0 k then is equal to 4 and k plus plus. Int nr is equal to r plus dr k and int nc is equal to c plus dc of k, right, dr and dc. Now if nr c is equal to 0 and nr n and nc of 0 and nc of m and grade of nr to nc is equal to 1 and not v's of nr to nc, then DFS of nr nc grade and viz, right. This one now try to compile. There is an error. Yes, the error is viz was not declared in the scope. Line number 5. Oh, that is my bad. Vector int of which. Now I just try to see it will turn or not and showing some error. So yes, and now yes, it will pass the test cases, all the test cases, and submit it successfully. So in that, the time complexity of this order of n into m, and the space is 1 for the visited, 1 for the recursion. So the worst case is n into m, right. So this is the DFS, and yes, we have to optimize this, and the optimizations is better, that means BFS for the last grid, right. So that means the same way, the same time complexity is order of n into m in the BFS also, and a space is also order of n into m. That's not a difference thing. Yeah, in a third and the optimal approach, we just optimize the modify grid direction. In that, the time is order of n into m and the space is order of 1. So that's all the approaches. So I hope you will understand the whole concept. If you have another ideas, please write on the comment section, and thank you so much.